Well, if r is this function of theta, and we know that x is r cosine of theta and y is r sine of theta, then x is equal to this function of theta, 4 cosine 3 theta, times cosine, and y is r, this function of theta, that is r, times sine of theta. So, finding the derivative of dy dx, we have dy d theta, derivative of this with respect to theta, divided by dx d theta, the derivative of that with respect to theta. If we are going through the pole, then we know that r of some theta value is equal to 0 because you're at the pole. That means f of that theta value will be 0, which means this will be 0 and this will be 0. So then the slope is just equal to this part. Well, the f primes cancel out. So the dy dx is equal to just sine over cosine, which is tangent of that theta, if you're going through the pole. So this is just another explanation using our derivative formula for parametrics, for polars. It's another explanation of why when we go through the pole, when your r is 0, the slope of the tangent line at that point will be tangent of theta, and the equation of that tangent line will just be y equals tangent of theta, the slope, times x.